this is the easier of the two proofs in this particular problem that we have to do. So I want to use the fact that the derivative ln of x is 1 over x. So that means, like, given that the ln x prime is 1 over x, I want to prove that the derivative e to the x is e to the x. So we did it the other way around. We started with this and then proved that this was true in class. So this is going to kind of be the same process, but sort of in reversed. So I know that ln and e are inverses, just like square root of x and square, right? So when I do an inverse function, like square root, and then I do it, or when I do a function like square root, and then I do its inverse function like squared, then what it pumps out is x. It gives me the original input, which in this case was x. So I'm going to use that property. I'm going to say that ln of e to the x, well, I know that that is equal to x. Now I'm going to take the derivative of this. I'm going to do dx. So we're assuming that we don't know the derivative of e to the x. So the first part of this is I've got some chain rule. I've got ln of blah, 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 and then I've got my blah, blah, blah in the middle. So I need to do my blah, blah, blah prime, which is, I don't know what e to the x prime is. That's what I'm proving. So I write it as e to the x prime, like that. And then now I do the ln part, right? So the derivative of ln of is 1 over that of, right? So I've got ln of e to the x, so my derivative is 1 over e to the x. The right side, so that's that whole left side's derivative. The right side is x, and that derives to 1 because it has a slope of 1. And now I just have to multiply by e to the x on both sides. So multiply by e to the x, cancel, multiply by e to the x. And then I just simplify what I have here, and I get e to the x prime equals e to the x. And I'm done at this point. I've totally worked through it, and it's not that bad given one of these guys to prove the other. If I had this, you could prove this pretty easily. And as I showed you here, if I have this, I can prove that.